Good afternoon. I think I've got about 15 minutes, really just to share with you my personal perspectives on what universities should be doing around engineering educations in the era of AI. There has been a number of reports over the last 18 months, 2 years, suggesting that the UK GDP will increase by 10%. That's the equivalent of about £232 billion. We also know that the engineering sector contributes about 23% of the UK GDP. So that means there will be an additional £58 billion engineering needs to deliver if the UK to realize the benefits of AI by 2030. So the question is, are universities ready to produce the graduates that engineering companies need, existing companies and emerging companies? So I'll just repeat what I've said earlier. This is really personal perspectives. I've been in university education for the last 20 years. I worked in industry for 10 years, and I maintain very close working relationship with industry. So just to go through some context, you've already heard that the government has already made the announcement of the £1 billion AI sector deal. Also, the UK government has ambitions to increase its investment in R&D to 2.4 of its GDP. The implications of that, there will be a further 260,000 people needed in R&D. These are new people. This is at a time when the UK has got a shortage of 20,000 graduates. So what we have here, ambitions, aspirations of governments with universities that are really struggling to produce the graduates you need today, let alone the type of graduates you need in the future. So what is it universities doing about, which is really what I want to be sharing with you. So just some numbers to provide some evidence for what I've said earlier. So the student choices, what do students apply for? So UCAS data 2018 that home UK students accepted to study electrical, electronics, civil mechanical engineering is just over 13,000. That's in 2018. That is significantly fewer than the 15,000 students who accepted to study computer science. I think that trend is likely to continue. Southampton perhaps is one of the biggest engineering universities, and we're seeing that already. And talking to colleagues at other universities, they're seeing exactly the same thing. There are more students want to study computer science and less wants to study engineering. And that is not surprising. I think it's the extensive media coverage. AI tends to be associated with computer science and all those famous people who made billions out of being dropped out from famous universities. By the way, I would not recommend for you to drop out to be successful. And also, is the government has made a huge investment over the last 5 years in computing at schools, coding at schools. And there has not been similar investment in engineering. So there's no question that we need to train computer scientists, but equally we need to train engineers with understanding of AI. I thought you may be interested in to see this slide, which shows the number of students who accepted to study electrical, electronics, civil engineering, and mechanical engineering. So the blue one is mechanical engineering over the last 12 years. So the picture is almost static, apart from there is growth in mechanical engineering students. So the title of my talk had the word AI system. What do I mean by AI systems? I thought I'll be able to explain that really with 2 simple examples, which we often see in presentations. The first one is an autonomous vehicle, and the second one is smart city. So the aim of AI, or at least that's the promise of AI, that it's not machines and humans replacing each other, but they're working together. So for machines and human, for infrastructure and human to work together, there has to be a system that brings them together, and that is the AI system. The AI systems will sense data, will understand data, will act on data, and will learn from that. So AI systems are not something completely new. It is really evolutions of what we've been doing for years, which is electronic systems. So in the first example, it is very likely that the car will do things better as it learns from the person who's using it over time. It's very likely that the smart city will manage traffic better. It will allocate resources better. But what it means, it needs to have the infrastructure around managing the data and making sense out of it. And data science really is very much about taking data and generating knowledge and using that knowledge through machine learning to make decisions. So data science, machine learning go hand in hand. But without engineering, we will just end up with machine learning in surfaces, which really what we see at the moment. There's a lot of machine learning in surfaces, but there aren't enough machine learning in engineering systems. That is what a university such as Southampton wants to do, wants to embrace engineering in the era of AI. So I'll just try to summarize. So AI systems is much broader than machine learning algorithms. They combine software, electronics, pervasive connectivity, and the two needs to work together. And such AI systems will underpin almost every autonomous system of the future. So the first key message from my talk is very much, I believe AI systems are electronic systems of the future. To give you an example of that, this is work we have done with a number of companies in the UK where we wanted to embed intelligence in how software, runtime, operating systems make intelligent decisions based on learning from past decisions. So what you will see at the bottom, this is a conceptual picture of an applications running on a piece of hardware and software in the middle. The monitors, if I could, yeah. So the monitors pick up data from the hardware. The runtime management analyze the data, understand the relationship between the data, and generate knowledge. And that knowledge will be used by the runtime management to make intelligent decision. And the intelligent decision comes from what it has done in the past. So if an operating system made a good decisions, and a good decision, for example, expressed in terms of the amount of energy the hardware consumed, it will keep it. If it made a bad decision, it will keep it, but try to avoid using it in the future. So what we're seeing here is an electronic system that has got intelligence in it. That is an AI system. That is just one example of an AI system. Again, the learning was done by what is known as reinforcement learning. There's a lot of talk about learning, deep learning, neural networks. This is not what we have done here. This is reinforcement learning, which is a sophisticated optimization algorithms which observe what's happening now. It makes a move. If the move produces something better, it will keep it. If it makes a move which gives you a worse response, it will forget it. And that's really what reinforcement learning is. And there's a lot of AI systems commercially available. At the heart of that is reinforcement learning on top of existing software working with existing hardware. So Southampton, as well as with a number of Russell Group universities, the last couple of years, we started to reimagine what would engineering education look like. Again, this is really my own terminology. I will start with the second message, that 21st century engineering is digital engineering. And digital engineering is the convergence of engineering practice with machine learning, data analysis, applied mathematics, and statistics. That is digital engineering. It's built on engineering principles, but in the context of data and intelligence. Currently, the UK has not got a systematic approach in updating their engineering curriculum. I'm urging, there's a group of colleagues working with the Royal Academy of Engineering, with the IET, British Computer Society, trying to create a momentum which will allow UK universities to embrace digital engineering in a very coordinated way, where students will be learning about data analysis. Engineering students, I think most of you perhaps had engineering educations at universities. You've learned about mathematics. So what we're going to do, we're going to learn mathematics in the era of AI. We learned a lot more about data visualizations. We learned a lot more about identifying variables in data and doing something useful with them. We will move away from Laplace transforms, Z transform. Some of you may be aware of this terminology. So we're not going to change the curriculum completely. We're just going to update it in the era of AI. So that's my second message. So it doesn't matter what we call it. I remember spend a lot of time talking to colleagues at universities about this, and what I get is what we're going to call it. And I said, I really hope we're not going to spend 5 years talking about it. We need to do something about it. So we could call it AI system engineering. We could call it digital engineering. We could call it anything we like, as long as engineering educations of tomorrow, it's not what we've learned a while back. It needs to embrace machine learning, data analysis, applied mathematics, and statistics. I think there has to be a stronger partnership between academia, industry, and professional institutes. I think the engineering professional institutes in particular have a really important role to play. They credit programs at universities. They should be looking at curriculum and saying, is this what produce graduates who are fit for purpose to enable the UK to be leading in digital engineering? Sadly, they're not there yet. We've already heard about industrial strategy and the amount of funding has been allocated to it. You may be surprised to hear that recently Office for Students are responsible for making sure that students get value for money when they go to university. So that's a very noble aim. That's great. They put a call out for £13 million asking your universities to produce MSc conversion courses for non-STEM graduates. So if you have got a degree in psychology and you want to become an expert in machine learning or data science, you could attend one of these courses. There has been no investment around how do we underpin digital engineering educations. Southampton is a well-resourced university, but I'm finding it difficult to build labs for digital engineering. There is no source from the government which we could apply to. So if you have the opportunity to talk to ministers, to policymakers, please don't forget about engineering. Not just because it's doing well, it means it's going to continue to do well. It needs investment. Those who have interacted with the university would have recognized how important the technical staff in laboratories are. We do not have technical staff who understand digital engineering. We need to upskill that. So if I would just try to finish off with what would digital engineering, or whatever we call it, curriculum would look like. Given that human machines, infrastructure, humans going to need to work together for the benefits of both. Humans will get the user experience and the infrastructure will run for longer, safer, and so on. So that means that students or designers of the future need to understand psychology, need to incorporate human behavior as part of engineering design. Decision-making is not going to be entirely by one part. It's going to be a collaborative decision-making between a machine and a human. That is ethic. And should the curriculum be coverage of that? What is the impact of all these automations? I personally think what we call design-based approach in learning, which universities have been using for years, including Southampton, which is very much, we teach you the principle, we give you a problem, apply it, and if it works, good. If it doesn't work, we tell you where it went wrong, correct it, and over time, you will be an expert at it. So it's very much about understanding and applying. I personally feel this type of teaching may have come to an end. There is some innovations in medical educations. It's called problem-based learning. There they look at an open-ended problem. They learn what they know, they apply, but they're capable of knowing what they don't know. So in medical education, it is okay for you to say, I don't know this. But you have the skills to go about finding what you need. And I feel we need to move away from design-based approach of learning to problem-based learning in the era of AI. And I think the role of industry and professional budgeting curriculum coordinator is going to be crucial. So I would really welcome anyone who wishes to talk to me afterwards to see if, one, what I said makes sense or did not make sense. Two, if you want to be part of the work we are doing at Southampton, other universities, in designing curriculum for digital engineering. Thank you.